Hello, Matt Davis here with some more video quiz help. This one is for the Chapter 6 review quiz. Let's jump in and have a look. The lap speed y in seconds for a particular car at a local racetrack is a normally distributed random variable with mu of y equal to 58.73 and sigma of y equal to 2.9803. Suppose a lap is randomly selected for this car. Find the probability that 54 is less than or equal to y is less than 61, and round your answer to 4 decimal places. So the first thing is, in the interest of giving help but not answers, we're going to change the question. So we're going to look at the probability that 53 is less than y is less than or equal to 62. So different numbers, some little changes in terms of the boundaries there. None of that's going to make too much of a difference in terms of process, though. So let's jump in and have a look at that process. First thing I would do is draw a bell-shaped curve. So we'll throw that bell-shaped curve in there. We want to label the mean at 58.73, and then we want to put our boundaries on the picture. And that's one of the first places that things can start to go a little weird for people. Here we have a less than symbol, but here it's less than or equal. So people start worrying about, well, how do I deal with that, right? What do I do with the 53 not being included when the 62 is? And the answer is, for continuous variables, it just doesn't matter whether the endpoints are included or not. You just use the number that you're given. And so we just want to think about that. What is our variable? It's the lap speed in seconds. So when you're measuring the time it takes for a car to go around the lap, yeah, you could get 53 seconds or 62 seconds, but you could also get 58.71923 seconds. You can get all kinds of messy decimal numbers for that, so it is continuous. The other thing that throws people off sometimes is they read 53 as less than y, and that less than gets in their head and they want to go to the left of 53. But if you just look at the overall notation, where is the y? Y is in between 53 and 62. So when you do your picture, you put the boundary 53 on the picture. Then you put the boundary 62 on the picture. And then what area do you want? Since y is in between 53 and 62, the area you want is this area right here between 53 and 62. So that's what we're looking for. An area in between two boundaries is actually one of the more straightforward things. So we just need to make sure we get it set up right, and then it's just a matter of getting the work done. So let's look at that work together. We'll start off with the z-score for the boundary on the left. We'll call that ZL for z sub left. So we want to take the boundary itself, 53, subtract 58.73, the mean, divide by the standard deviation, 2.9803, and round that to exactly 3 decimal places. So let's head to the calculator and work on that piece. So always remember to have parentheses around your numerator for z-scores. So 53 in parentheses minus 58.73. End the parentheses once you're done with the numerator, and then divide by 2.9803. So we get negative 1.9226. We need 3 decimal places, so negative 1.923 when we round that second 2 up because of the 6 that follows it. So heading back over here, our z-score on the left, negative 1.923. And then from the 62, you'll get your z-score on the right. I'm not going to write it all out. I'm just going to go compute it, because really what we're going to do there is we're just going to swap out this 53 for that 62. So let's go ahead and make those changes and do that on the calculator. Since all we are doing is changing that number on the left, I'll hit second enter to pull up our last calculation. Use the arrow keys to get over there on top of that 53, and then just type a 62 in its place. Press enter, and then I get the z-score on the right, 1.097, and we'll stick with the 7 because it's followed by a 2. All right, let's switch back and go write that one down, 1.097. Couple quick notes about the z-scores. 53 was to the left of the mean. I got a negative z-score. That makes sense. 62 is to the right of the mean. I got a positive z-score. That makes sense. 53 is further away from 58 than 62 is. And the size of the number here, 1.9, is bigger than the size of the number there, 1.097. I'm always thinking about, do the things I'm calculating match my picture? And if they don't, it can help me catch typos and missing parentheses, stuff like that. All right, so that probability we want is this area in the middle. When you know boundaries and you want area, that's where normal CDF gets used. So normal CDF, left-hand boundary is negative 1.923, right-hand boundary 1.097, and then I'll put that into the calculator and round that to 4 decimal places. So let's go do that. We know boundaries and we want area, so we're going to use normal CDF. So we go into the distribution menu, we choose normal CDF. Our left-hand z-score was negative 1.923, and our right one was 1.097. So we put those in, press enter, we get 0.8364, sticking with the 4 because of the 3 that follows. Switching back over, 0.8364. All right, that's the area in between 53 and 62, so that is also the probability that y will lie between 53 and 62. Yes, including the 62, but not the 53, but that really doesn't make a difference when it's a continuous variable. Just use the boundaries you're given regardless of whether they're included or not. So there's the process, some things that can go wrong. Shading the correct spot on your graph. And again, if y is between those two numbers, you should shade between those two numbers. It's continuous, so border inclusion is not irrelevant, so it really doesn't matter. You never adjust it to 54 or to 61 or 62, 63. You just don't change it. If it's continuous, whether the border is included or not doesn't matter. Then the other thing is just making sure you're being careful, putting the z on the left in first into normal CDF. So z on the left first, z on the right second. If you mix up that order, you'll get a negative answer, which doesn't make any sense for probability, so pay attention to stuff like that. Whatever did go wrong for you as you were working on the quiz, I hope you saw the correction to that here and that you're ready to go tackle that again. So good luck as you head back to the quiz.